They put the waste in. The waste is burning inside this furnace. Furnaces. Called this one is mobile floor, and it's called stoker. And the waste is gradually transported from this to complete incineration. Here, this is the furnace room here. Incinerator which burns refuse. There is a moving floor called stoker, and the incinerator for slowly moving the refuse inside burning to 4 to 5 hours. Kiln type, this kind of stoker type or mobile floor type. This is a mobile stoker. It's supplied from this direction, and this is angle, and this floor is moving. And when the waste is put on here, and this stoker is pushed waste, and then push the waste like this. And this kind of brick is very strong against the high temperature because the average temperature inside the furnace is 850 degrees. Because if you burn the waste under 500 degrees, the more dioxins generate. So you need to burn the waste at high temperature. It says that there is heat for the power generation. And on the incinerator there is a device like big kettle called boiler, which generates steam with heat when liquid is burned. Electricity is generated with high temperature and high pressure. Steam generated in the boiler by rotating a runner directly connected to the generator called turbine. Or heat generated by burning refuse is therefore recycled. The maximum electricity generation power is 25,000 kilowatt, and it is to use the operation plant, and the remaining electricity is supplied to the electric power companies. Yeah, it says the steam pressure and temperature is 4 megapascal and 350 degrees. The steam. This is the steam temperature, and this is a maximum vapor. Is this amount 63 tons per hour. Like this here English explanation. And it says the electricity generated here is covered the 67,000 households. Not much, because we have 1.6 million here in Fukuoka City, and like 7,000 households. Electricity is supplied from this. Not the products, residue generated from the burning. So they send ash after the incineration. Here, this is ash pit, and they have a crane here and put ash, grab the ash, and put it into the truck and bring it to the landfill. So this is ash pit. No, here they. This from receipt. This heat where comes from. This from receipt. Electricity. Heat is coming from the waste. So you have access to the continuous cycle and burn in sufficient heat, and they recover the heat by using steam pipe.
Some waste are wet.
What?
Some waste.
Waste.
Wet.
No, yeah, of course. some part of the waste is wet, but the how to say? Of course, the wet moisture contained in the waste prevents heat generation, but the paper and plastic has sufficient calorific value to burn it without any kind of fuel. So this is very important part of the Japanese waste management system, because if you add the fuel like oil or coal, they need how to say, they are using the fossil fuel and it's generating carbon dioxide. It's not good, so we don't add any fuel. Only the starter of the furnace, they put some amount of the oil to start a fire, but after that they don't add any. So this is very important. So it's a very good question.
I still cannot imagine the household waste can generate more than 850 degrees Celsius. I think they can generate around 300 or 400 degrees Celsius, but 800.
Yeah, because technology. they supply a high amount of air into the furnace to have a high temperature. So there is technology to keep the high temperature, but only by the waste.
That is very amazing.
Yeah, because it's how to say it's possible by waste generated from Japan, because in to burn itself, so they need to add some fuel to keep the high temperature. But in Japan, we have a lot of paper and plastic waste. But from now, we are planning to separate plastic from the combustible waste. After that, it's very skeptical. We can burn without the plastic at high temperature or not. So it's a challenge.
That's a question. So if amount of CO2 from this compared to like from coal or from other electric generator, how much is this? Yeah.
That's a very good question. So the garbage has a calorie.
Yes.
Maybe the average calorie is the same as the coal average, but coal is purely fossil fuel. And garbage, some of the garbage is originated, but like paper, the wood is biomass. So biomass carbon dioxide is called neutral carbon. So we don't need to count as carbon dioxide. If you burn the plastic or other fossil fuel origin waste, that's carbon dioxide is pure additional carbon dioxide generation.
It is methane and vehicle.
There is no methane from the insulation, but we have some waste. So we have to, when you are going to calculate carbon dioxide generation from the waste burning, you have to separate two kinds of waste: biomass waste and fossil origin waste. And the biomass waste carbon dioxide is not counted. And only the fossil fuel origin exists. Because biomass, like paper made of trees, when the tree grows, they absorb the carbon dioxide from the air. So that's the natural cycle of the carbon dioxide. So we don't need to calculate carbon generation from the paper.
It's not an extra.
But the fossil fuel is different. In the front. So that this working time is 24 hours, maybe 3 shifts, 8 hours, 8 hours, and 3 shifts. I'm not quite familiar with those things, but it says that this is material used in the furnace. This is anti-heat, anti-acid material, and this is a chemical to stabilize some heavy metals in ash. And this is, I'm not quite sure about those things. Maybe some wastewater and waste gas, exhaust gas treatment equipment. Yeah, here, this is a boiler pipe. They install this kind of pipe on the wall of the furnace, and inside the pipe they supply water, and the water absorbs heat from the furnace and becomes steam, and that steam moves the turbine wing and generates electricity. Yeah, this is bricks, anti-heat bricks, anti-heat block stoker. Very important. Actually, we come from this way and park the bus around here, and we go up and like this. And here is the waste pit. This is the waste. No, that does work. So it's very difficult to explain. This is the furnace, and you can see a big equipment at the center of the plant. It is called bug filter. Bug filter is like a socks, your socks. There are a lot of socks is hanging from the roof, and from the outside they send the contaminated air, and they how to say it's very difficult. Socks inside is very clean. Socks outside is filled with the contaminated air, and the socks is works as a filter to catch the contaminants contained in the gas from the furnace. So it's very important equipment. Bug filter is kind of air pollution treatment facility. The size is very big. So we have two residues from this plant. So one is called bottom ash. Bottom ash is ash generated from the. It's generated at the bug filter. I told you that there is a lot of socks. It's coming from the roof covered by the contaminated particles. And then when they apply the shock to the socks, the small particle is dropped down. And this is called fly ash. The fly ash is very toxic because some of the metal evaporated after a while during the burning, like lead and cadmium and some toxic metals contained in the fly ash. So fly ash is recognized as a specially treated waste. Do you remember in my lecture there are normal waste and specially treated hazardous waste? And fly ash is one of the specially treated waste. It's very toxic. and they apply some chemicals into the fly ash to stabilize toxic substances to prevent those things is leached out from the ash. Anyway, both of the fly ash and bottom ash generated from this plant is sent to the landfill site, where we are going to visit after this spray plant. Fly ash and bottom ash.